Hello, everyone. Are you energized today? Do you feel it's going to be an awesome day today? Great. Then we're on the same page. A good start here. All right. So when I talk, I want the audience to, be, alert, aware of anything. So if it's something that you don't understand or you want to, ask a question, just raise your hand and, I will just try to answer a question. Or if you're too embarrassed or whatever, you can ask me afterwards. So that we are all on the same page. All right, so my name is Alexander Andelkovic, and I work at King. Does anyone know what King is, the company? Does anyone know the mobile game Candy Crush Saga? Yeah, so we the creator of that game. And I'm here today to talk about our journey with how we started out with using artificial intelligence in software testing. So that's the topic that I'm going to talk about. But I would say that the presentation is divided in 3 parts. First, it's a little bit of an intro about how we work at King as QA. And then we have a little bit more of an AI technical part, and then the last part is more like, okay, what can you use it for? How can it be, of use for you? So that at that section, it's good if you guys, ask me questions like, oh, we know, where should we start? Or, we have tried it and it sucks, or, whatever question you have. Right? So let's go. Yeah, so King has been around since 2003. The company started out doing web games, and then was lucky to, launch a mobile game when Facebook was really, popular. So today we have around 250 to 300 million monthly players, and we're around 2,000 people. We have 13 offices around the world. And we got acquired by Activision Blizzard. They thought that mobile casual games is something that they wanted in their portfolio. So what we have done is that we have made casual gaming into a franchise. So when we create games, we don't create a game and think, okay, this game will last for 2 months. When we create a game, we think, okay, this guy should be around for 5 to 10 years. So if you have that requirement on a game, there's a lot of thought process involved into okay, how should we pick the right game to, put all of the effort in. So what we do at King is that we work data-driven. And what that means is that we collect a lot of data from the users when they play, and then we evaluate that data and modify our game depending on the learnings that we get from the data that we have collected. And the roles at the King QA, we have the agile testing leads. They're like a test lead, but the idea with them is that they should try to be quality assistance people in the teams, not quality assurance people. So the difference there are the quality assistance people, they try to get the team to own the quality, and not just one person, and then that person get the blame if there's a bug that slips through to a release. So then the whole team are responsible for, if there is a bug that slips through. So that's a little bit of a difference in attitude when it comes to QA. And then we have the QA analysts. They're I would say they're mostly manual testers. And we have testers that sits within the teams and that sits outside the teams, but are borrowed in, depending on, if there are a lot of things that needs to be tested or not. And they're, I would say they're exploratory testers. And then some of them are technical, so they might script, and some others might just focus on the regression testing and the smoke tests and the exploratory testing for a game. Then we have a quick regression test team, and that's for every release we have a full test run. We test through like the whole game, and it's around 1,000 test cases. So we have like teams that are dedicated. They're specialists in testing those 1,000 test cases, and they do it in 6 hours. So when we have like a major release, we let them run test through a whole the game, everything before we release it. So those guys are they're really valuable. We are lucky that we have a team like that inside of the company, and they do a lot of good work, I would say. Then we have test automators, and they are spread around the company where needed, and their mission is a little bit like the ATL's role, to try to be like an ambassador for test automation. So they're trying to work together with the developers and help them to get test automation going in the teams. So usually what they're doing is they work with test automation frameworks and coach the developers to think you need to automate the code that you're about to ship. And then we have data scientists. So we have the people that are analyzing the data that we collect. And they are also testing, but they're testing the data. Normally the QA people has been focused on testing just functionality. Press this button, something breaks or not. But also the data can be corrupt. And when they are analyzing data, they usually quite quick see when something is wrong, because they have like a graph and then it just goes down and they're like, something's wrong here. And it's usually due to a bug or a configuration issue in the environment. So they are also like testers, I would say. And then we have the developers. So they're becoming more and more testers. And I would say the best way for them to become testers, it's for this QRT team not to test, because there will be a lot of breaking changes, and they will not sleep well. And then they realize, okay, we need to contribute when it comes to quality. So sometimes it's good to feel the pain before you realize that you need to contribute to make sure that the incident doesn't happen in the future. All right, does anyone have any questions about this? Or is it crystal clear about how we work with this? I can mention one thing. At King, we have game studios. They're focused on making the games themselves. And then we have a game platform team. So what the big game platform team focus on is to make the platform that the game use. And the platform consists of analytics functionality, social functionality, payment, stuff like that. So there are two types of testing, I would say, that are going on. And the testers have have missions. So we try to interact and collaborate and share and stuff like that. So that's also good if you have people that are doing different things, that you try to meet and together try to learn from each other. Right? So at King, Candy Crush has more than 2,000 levels, and it becomes more and more, I would say, challenging to test through all of these levels, because we need to test them, otherwise we can be sued by people that are paying for playing the game, and if a level doesn't work, it's a faulty product. So we've been thinking how can we test the levels in a smarter way than manually. And one thing that has become really popular is artificial intelligence. So we were okay, why don't we try it out? And I'm not sure if you know what this is, but to the left is the world champion in chess. He got beaten by a computer. And then there's the world champion in Go. And he also got beaten by a computer. And I would say this computer used more, traditional artificial intelligence The one that one used was a little bit more brute force. It was more like hard-coded, while this one was more like learning by itself. So a bot, does anyone know what a bot is, or don't know what a bot is? Okay, I help you out. So a bot is like an application that performs something automatically. So when we were like looking into like artificial intelligence, we were like, bots. That's what was mentioned. So what you do is that you make these intelligent bots, small programs, and what they do is that they run through your program, and they have like a mission. So we train them for a specific mission. And how do we train them? Because there can be different challenges. We might want to use them when we do level design, to measure the levels. Are the levels good or bad? Normally, we let the end users measure that. But a smarter way is to let a bot measure that before you release the game. So then there's like, how should you do that? Also like QA, how should you do QA with the AI? So we were like thinking about this, and also like the data. We saw that the data, probably a bot can go through all of this data instead of you have data scientists that manually try to figure out what works and doesn't work in the code. And we were like, okay, we were thinking like the bot needs to be quite general. It needs to be, be able to handle different missions. And we were like looking for all different algorithms. There are like a lot of artificial intelligence algorithms out there. And the one that we found was Monte Carlo Tree Search. Does anyone know what Monte Carlo Tree Search is? Okay, so what that is it's an algorithm that goes through all combinations. So if you have like a game board, and you have maybe like 3 options where you can pick, you don't know which one of these is the best. So what you do is you let a bot with this algorithm go through all of the combinations, and it plays through the game and make a rating for every move. Was this a good move or a bad move? If it completes the level, then it gets higher points. If you fail the level with a move, then you get lower points. So what that ends up in is that you can have like a map of a level, like how difficult a level is to play or not to play. And to visualize that, you can draw like this graph here. So what you see here is at the arrow, that's when you start a level. The ring in closest, all of the branches are different moves that you can make when you play the game. So what this bot does, it goes through all of these combinations and play them out. And it goes through to the bottom. At the bottom is like if you have completed or failed the game. So if you put colors to it, okay, maybe not that good, but the green colors are moves that are good. You completed the level when you played with that path. The red ones are, you failed the level. It was not a good move. And this is how it looks like if you do it in runtime. I was asking the AI engineers, can you visualize this? Because it might not be simple for people to understand. So they made this. So you can get some kind of idea of what the bot is actually doing. And so we were like happy. In this graph, what you can see, this curve here represents, here is a perfect playout. When we create a level, we have like, you should complete this level in 20 moves. And if you do that, that's like a perfect play. Then you have finished the game the way we wanted, that we predicted that you would finish it. Sometimes you might need more moves or less moves. If you need more moves, then people, either they can be, quitting because they think, oh, this game is too difficult. If the player needs less moves, he can quit because he thinks it's too easy. So the best thing is we can find this balance where it's challenging enough, where it's not too easy and not too hard. So what we do then is that we try to train this bot to measure the levels. Where is the level where it's not too easy and not too difficult? And what you can see here is this is human testers. They're like quite good at being at this ideal level. They have a tendency to be better because they learn. We use testers to test this, and they learn the levels. So they're like cheating a little bit because they know what tactic strategy that's used to finish the level. The bot starts from scratch. It doesn't know how to finish the level. It just explores it and evaluates afterwards if it was good or bad. So what you can see here is that this is the human player when they play out. The orange one is like a bot without AI. It just randomly goes through the level and have no clue if it was a good or bad move. It usually underperforms because it can get stuck a lot of the times. So then it's like, it's not ideal, I would say. And then the green, the pink, and the yellow one are bots with AI with this Monte Carlo Tree Search algorithm. And that's the number of iterations. Like if you play 50 moves, 50 times, you can get close to it. And ideally, around 150, if you play the game 150 times with a bot, it are almost on the human level when it comes to play out, in figuring out, okay, now I know how difficult or not difficult this bot are. So I'm not sure if you understood this, but yeah, question?
Thank you. Do you have any random generators, like random factors, when you make your moves? So level can have different data each time. How you working with that? Or each move causes same situation every time?
So what we do is that we let the bot. The bot can only know about valid moves. That's the only thing we give to the bot. He doesn't know anything else. And then it plays out and evaluates afterwards. So that's the approach that we're using. So we're not like in some way preparing data or something like that for it. It's more like we are evaluating its play out.
But the game itself, is it generates random data or not?
I can't tell you, but you can figure it out, I think.
Okay, thank you.
All right, we can talk later about it. Okay, so we were like quite happy with this Monte Carlo Tree Search because we saw that we could use it to play the game and get like a mapping of how difficult or easy the game is, and then we can tweak it from that. There were some, it was time-consuming for the bot to play through the levels, so that was something that you can work on to optimize it, the algorithms. So what we did was that we found another algorithm called NEAT, and that's like a neural network. So it's a little bit like a mini simulation of your brain, how your brain works. And the difference between this one and the Monte Carlo Tree Search algorithm are that this one, you take the result and you tweak the algorithm in real time to make other playouts. So the playout might change a little bit. And the way it works is that with the Monte Carlo Tree Search, when you do a move, the bot doesn't know anything about what it's doing. It just makes the moves. And with this NEAT algorithm, what you do is that you create like an army of bots that have different missions. One bot can have a mission to, you should only go for the blue candy. Another one can have, you should only take the striped candies if you see one. And what they do is they play the game with that focus. And then what we do is that we let them play for a while. And then we pick the one that performed the best. And then that had different missions. And then we crossbreed them. We make a new bot that has the experience from both bots prior to this new bot. So then the new bot has the knowledge of what the two prior bots did. And what happened then is that you get an understanding of like, okay, here is a striped candy. This one is really good together with a green candy. And then if it sees that, it will make that move. So then it can like, perform better. And what we are using it for is to, I can show you here. Here's like a visualization of how that algorithm works. So what happens here is that you have the green diagram at the bottom. That's the number of this bot with the single missions. That's, for each iteration, when we create a new bot, you get like, more and more bots. And at one point in time, the bots are not going to get any better because they're, completing the level at the maximum, rate. So then we just do a reset and start over again the process. And then we do that until we see like, okay, this is not getting any better. And then we're like, oh, that's a criteria for being done with this simulation. And at the top graph, what you can see, the yellow ones are the average score of each iteration for all of the bots. And the red one is the best bot, its score. So, you can cherry pick the best ones from, a bunch of them. And here you can see the best bot in each iterations, how its nodes are connected. So if you run the animation with this, so what you can see here is, with this curve here, it goes up, and then it doesn't get any better, then it starts over here, and then it do this until it come to this state where it's, we're not getting any better here. And here you can see which one it picks. So this is how it looks like when a bot with a artificial brain is playing a game. So now you know how it looks visualized. All right, so the learning that we got from running this neural network bot algorithm was that it was a candy game was not designed for, when they created the game, it was not prepared for using artificial intelligent bots. So what we needed to do was that we need to do like a, go into the code and adapt it so it would work. And what we realized was that this is not optimized at all for running a bot, because when you run a bot in an application, what you want to do is you want to be able to go to a point in time and start from there. So like if you play and fail, you don't want to start over from the beginning to get to this state and continue with another option. So if you're gonna do some kind of artificial intelligence testing, first question you should ask yourself is to like, can we add support to have states that is, you should be able to save every state of your applications, so you can jump to a certain state and continue the simulations from that state. So what happened in our case was that we needed to run through all of these states all over again. So what happened was like, here's like a graph of the total execution time. And the green one is like, this is the time it takes to get to a certain state. And then the yellow one, that's the time it takes for the AI to do the thinking. And then the purple one is, the pink one is the time it took to play out the game. So if you would have an application that would have support for states, the green area and the pink area would be looking like the yellow area. So there's a lot of improvement that you can do, and optimization when it comes to like doing these simulations. All right, so a practical example. What did we do with this bot? Then we had played around with it, and like, okay, who could use this? So we have like level designers. So the way they work is first they create a level, then they give it to a tester, they test it, and then they give feedback to the level designers. This level is too easy, or this level is too hard, and then they tweak that. And also we have this data analytic people. They look at under a period of time. Okay, we have like had 10 testers. They've been playing these 10 levels for like a week. How are they, performing? And they also give feedback to the level designers. You need to, change this level. It's too easy, or it's too difficult. So this process can take from like a couple of days to a week or two to get it right. And then you launch it to our users, and then that's usually when you know how good you were in tweaking, because you will see how many players are going to play this level, and then you get that feedback back after like a week or two. So the level designer might get like after like 3 or 4 weeks, he will get more feedback of like, you need to make it even harder or simpler because it's not fun enough, and people are like, they don't play this level. So the whole process can take, from a couple of days to, 1 week or 2 or 3, worst case scenario. So with the bot, the scenario looks like this. The level designer, he creates a level. He let a bot play through the level and give him a measurement of, this level was too good, too difficult or too easy. And he will get that feedback in like 30 seconds. So he can like, immediately fix it. So it's really close to like, this ideal difficulty. And then the BPU, he doesn't need to monitor this for like a week and give feedback. So you can just ship it immediately to the end users. And then we have like another bot that measures the end user's performance and compares that to the bot's performance to see if they are, big difference or not. So with this process, in the beginning, the level designers, they were quite afraid that the bot would steal their jobs. So they were a little bit against it. But now they love bots, because now they get more time to, be creative and create more fun levels. They don't have to worry as much about, will this level be a good one or bad one? They will know that in 30 seconds because they get the immediate feedback from the bot. Right, any questions on this? Good. All right, so to summarize this, the bot, if you're gonna do this yourself in the future, or if you're gonna, redo it, if you have tried it and, didn't work out. The good thing, as I see it, I think the experience that we had with it was that it can help out in areas where you didn't think from the beginning. And I think you should have like an open mind when you, look, what should we use this for? And, ask the question, can we use the bot for this? Can we use it for this? And then for some things, it might not be as good as for other things. But like in our case, for level design, it was really, really good. It helped out. And also for QA, when the bot are doing the simulations, it exercises the code and trigger combinations that are really difficult for a manual tester to trigger. So we find a lot of, difficult to find crashes with the bot. So the developers are really happy that they get this thorough testing for free of the game logic by the bots. So that was something that we didn't do anything, we just got it for free. And also the data scientists, they're like getting quicker feedback on what works and what doesn't work. So they're also like happy that we have this new tool that are helping them to they're able to evaluate much faster now than they did before. And challenges with AI or bots, I would say, the learnings that we have had, I would say, are if you're going to do it, who's going to own it? Who's going to fund it? Like, who's going to, what resources should we take? Should we hire new people, train existing people, or do like a combination? Should the people sit together in a team, or should they sit, spread out in organization? So what we did was that we hired some students that was like studying machine learning, and told them like, if you can do this, it might be a bright future for you here at King. So now we have like an AI team at King. And what they're doing now is that they're building like an API so that other games can use this, the findings that they have, come up with. And so on a technical level, the challenges are that your application needs to be prepared for AI. And what that means is like you should be able to run the application without any user interface, no GUI, because otherwise it will take too long time to do the simulation work. So you need to think about that. Can we run our application without the GUI, like in headless mode? So that's one of the first questions. Another one is these states. Can we save the states of our application? Or, will we have performance issues? And also like, when should we start this? A good thing could be to do it as a hack thing, or dedicate a sprint to, get going, try it out. Aim to make it like agnostic, so you can use it for multiple things, and not like, this bot can only do one thing. So I think it's good to have the mindset, how can we make a general bot that can do a lot of things? Because then that will help you when you're going to make decisions, what type of algorithms are we going to, focus in trying to use. And then also, like, when you have this up and running, who's going to maintain it and sell it? Who's going to keep the infrastructure in place and scale it up when more people start to use it? The support of it and stuff like that. Train people. That's also questions that will pop up that you need to think about. So if you can think, we thought of them after we did it because we didn't know. So I'm just sharing now that this is thing that you probably should ask yourself before you start a project like this, because they will pop up, and then people might be upset if they're like, oh, why didn't you tell us that we would have this to think about? Yeah, and here are some links if you have access to the presentation. If you want to look more on a technical level, how we did it and what we have been doing. There are like papers on it that this thesis student wrote, so you can look into that to get a more deeper understanding of the whole thing. And questions? I think I have a couple of minutes left. So do we have any? Yeah, question in the back.
Hello. So are you also using those bots for the, for the performance stress tests, or, causing some troubles to your game?
I would say not at the moment. The only stress test we do is the one that we get for free by, running the exercise in the code, a lot of the times. But that's not anything that are planned. We're just, tapping into that for free. But of course, that's something that we're probably going to look at later on. Okay, how can we train the bot to be more, focused, from a performance point of view? But that's not, the initial thing that we want to use it for.
Thanks.
Thanks.
Hello.
Hello.
Do you have a UI test for bot?
Can I
Do you test your game as UI test? Do you have?
We are working on that. Now we've been focusing on the game logic to test that. So next thing is the UI. I would say like, yeah. So I guess what we're trying to figure out now is how can you test the UI in headerless mode? So we try to evaluate that at the moment to see if that's possible before going, all in not using it in, in GUI mode.
Okay, thank you.
Yeah. Yeah, here.
So hi, thank
Hi.
you for the presentation. So the question is, does the bot predicts one step only further or more?
So it depends. You can tweak that. I would say so. It's like depending on what you want, what questions you want to answer. So what this AI team, what they're doing now, they're like looking through a lot of algorithms and trying out, to see what algorithms can be, a benefit for us. So they're trying out different, approaches, I would say. So I would say we're trying that, both, I would say. We also like trying this reinforcement learning of, the reinforcement learning itself and stuff like that.
I think in one more thing, can the bot simulate different experience of the users? So like the user who plays the game a lot or the user who just started the game?
You're not interested of that.
Okay.
You're only interested of the majority players. The other one, of course, you can do that, but I would say that that's not prioritized. Yeah.
Thanks for the presentation. It was valuable, your experience. So my question is, could you give us a bit more details about technical side of things, like what programming language you used for prototyping, what programming language or technologies you use in production? Did you use any kind of cloud providers like Amazon or something like that?
Okay, so the bot are written in C++, because the reason is because Candy is written in C++. But now they've created APIs to make it code agnostic, so you should be able to use any language. More bots are being used. They're using Python now because they're using TensorFlow, and that's ideal to use. TensorFlow is this Google's tool to create these AI models. So they realized that they need to make it code agnostic. So the language should not, shouldn't depend on the language. And they're running it on an old PC, because at the moment we're not interested in the performance part. They have tried it out in Google Cloud. They have like a GPU cluster. So we have tried to run it there just from to see how much can we gain from performance. And of course, you can gain a lot, but it's not of importance for us now. The importance for us now is to learn which algorithms are good for us. So we're more interested in that than in executing them, as fast as possible. Of course, we're going to aim to try to execute them as close to real time as possible to do the evaluation, but it's not of priority at the moment.
Okay, and another question is,
Yeah?
I saw this great visualization, how was done it with some open source tools, or are some packages?
I don't know which tool. I just told the developers, make it, cool. And they made it cool. So I was like, okay, I'll take this one and use it. Of course, if you mail me, give me your email, I can ask them and reply if you want to use that tool. But I don't know which tool. It should just be a cool tool.
Okay, thanks.
Thanks. Yeah, question over here.
That's the last question.
How you test your game on different devices, on another version of mobile phones or iPods, no, something like that. Do you use some service or you buy those devices?
We have our own device farm, I would say. So we have like between 500 and 1,000 devices. So you can run, you can allocate. I want to run this test on 100 devices or 50 devices. So we have that and maintain that ourselves.
And do you use bots on those devices also? Or?
Yes, yes. That's the good thing with the bots because you can use it in automation. And that's the one thing that I'm looking into now. How can we use AI in QA, like, to help evaluate testing, test cases? How can you make them better and all that stuff? I've seen that there are tools coming out now that can create test cases automatically by analyzing the code. So I think that's coming more and more now, I would say. And also, like last week, I saw a tool where you can test like web pages with AI, where it learns how to click to do purchases, searches, and stuff like that. So there are a lot of things happening now, I would say, in the QA industry.
Okay, thank you.
Yeah.
All right, guys. Thanks, Alexander.
Thanks.